Alright, so this section is going to be all about ionic bonding, the first of the two types. Okay? So in an ionic bond, you have a metal and a nonmetal, a cation and an anion. Okay? So we're going to talk about how to name ionic compounds. So if we have a chemical formula, we need to know how to name it. So first rule, cation comes first, always. The cation, or the metal, always comes first. So naturally, the anion comes last in the name. Okay, for the cation, real easy. You just use the element name. Okay, for the anion, use the element name, but you drop the ending and add IDE, I-D-E. So I'll show you what I mean. So if you have NaCl as the chemical formula that you're working with, all right, for the cation, we just write sodium. That's our element name. For the anion, the element name is chlorine. So we drop the ending, and we add IDE, sodium chloride. So this is an ionic compound, and that's how you name it. So let's say we have, okay, CaBr2. Cation is calcium. Anion is bromine. Again, you just drop the ending and add IDE, calcium bromide. Okay, so that's all you got to do. All right. Let me give you guys a few practice problems, and I would pause it, and once you've answered them all, play the video again, and you can see if you got them right. So try this one. Okay, so try those three right there. So pause the video now, and then play it again once you got them. Okay, first one, calcium, and that's sulfur, so you drop the ending and make it sulfide. Next one, lithium, drop the ending of fluorine, fluoride. Last one, I don't know why I like calcium so much right now. Calcium, and that's iodine, so you change it to iodide. Calcium iodide. All right. Moving on. So that's the general rule. Cation first, anion second. However, there are a couple special cases. You need to use Roman numerals for transition metals. Okay, so let's say we had TiO2 or FeCl3. Okay, so in this one, if we look at this one, this is iron, we know that. This is chloride, we know that. Problem is, iron is a transition metal and we don't know its charge. Normally we use the periodic table for the main group elements to predict their charge, but we can't do that for iron. So we need to use Roman numerals right here to indicate charge. So what we do, we look at the anion. We look at chlorine up here. Chlorine has a -1 charge, right? 7 valence electrons means it has a -1 charge. Since there are 3 of them, we have a total of a 3- charge on our anion. Okay? That means, since compounds have to have a total charge of 0, always, iron has to have a 3 plus charge. Okay? Now our compound, iron chloride, has a total charge of 0. So we put that 3 right here, iron 3 chloride. Now the reason it's important to use those Roman numerals is because here's another compound. Okay? This is iron 2 chloride. If you just said iron chloride, you know, how would you distinguish the difference between those two? You can't. That's why you have to use the Roman numerals to indicate charge to tell the different compounds apart. Different compounds, different chemical properties, you got to tell them apart. Okay. Let me give you a few examples over here and see if you can get them. I don't know why I'm doing that one. Let's do gold. All right. Try these 3 examples and unpause it when you got them. Okay. Titanium 4 oxide. We did this because there are 2 oxygens, each with a 2 minus, so that has a 4 minus, 4 plus. Okay. This one here, copper 2 fluoride. Same thing. 2 minus means we have to have a 2 plus. All right, and this last one would be gold 1 iodide. Pretty simple. Iodine has a -1, so gold has to have a +1. Okay. So this is how binary ionic nomenclature works. Let me write that here. This was binary nomenclature, meaning only 2 elements. So if you look at every example we had, there's 1 cation, 1 anion, right? Titanium and oxygen, copper and fluorine, gold and iodine. The other type would be called ternary nomenclature. Okay? This is where you have 3 plus elements involved in an ionic bond. All right? So, an example would be calcium hydroxide. Okay? Use the same rules. Cation first, calcium. Now, for the polyatomic ion, this is the second part. This thing right here. Okay? You should have a sheet. It's a list of polyatomic ions. If you see a polyatomic ion, like OH right here, all you need to do, and this should be a 2, I'm sorry, all you need to do is use the name. Okay? OH is hydroxide, so this is calcium hydroxide. Okay? If you see CuNO3, all right, Cu is copper, NO3 is nitrate. All right. One thing we're missing here is the Roman numerals because copper is a transition metal. Okay? If you look at your polyatomic ion sheet, nitrate has a -1 charge. That means copper has to have a +1 to cancel it out. Copper 1 nitrate. All right. Try naming the following compounds. That's good enough. Try these 2. Pause it now, unpause when you get it. All right. Okay, it's potassium, PO4 is phosphate. Okay. NH4 is ammonium. SO4 is sulfate. All right. So we just talked about how to take a chemical formula and name it. Read the name of the compound. What we're going to do now is the opposite. So if I were to give you a chemical formula, you need to be able to, if I were to give you the name of a chemical, you need to be able to write the formula for it. So ionic bonding, still working on ionic. Now we're doing name to formula. Okay, so the first step here, step 1, determine the charge of all atoms. So let's do an example. I think that would be helpful. Let's say we have magnesium bromide. Okay? So obviously first, you write it out, magnesium and bromine. Those are the two elements that are going to be reacting. Alright? We don't know the ratio yet. We don't know the subscripts. So this is what we're doing. First step, determine the charges. Magnesium, being in group 2, is going to have a 2+. Bromine, group 7, has a 1-. Okay, so those are the charges of the two atoms. Step 2, use the crisscross method. This is an extremely helpful shortcut to writing the chemical formulas. So for this, all you need to do, take the coefficient for this charge, bring it down here. Take the coefficient for this charge and bring it down here, giving you Mg with a coefficient of 1, which you don't need to write, and Br, coefficient of 2, or subscript of 2. MgBr2. This is magnesium bromide. Okay? The important thing, really important thing to make sure to check your work, the total charge of the compound, and I've already mentioned this, has to equal 0. This is really important. Total charge of the compound has to equal 0. So we can check it. Br2. Br has a 1- since there's 2 of them. It's a 2-. Magnesium's a 2+. We're good there. All right. Let's say we have, let's do a polyatomic. Copper hydroxide. Okay. Okay. Our cation is copper, Cu. Copper 1 hydroxide, I'm sorry. Our anion is hydroxide, OH. That's a polyatomic. Okay. Step 1, determine the charges. Hydroxide, if I look at my polyatomic ion sheet, I can see that it's a negative charge. Copper 1 has a plus charge. If we crisscross, we just get 1 as the subscript for both, so we're good. Copper hydroxide is just CuOH. What if we had copper 2 hydroxide? All right. CuOH. Okay. Copper 2 has a +2 charge. So if you crisscross those charges, the 1 goes to the copper right here, but you don't need to write it. The 2 goes to the hydroxide. Okay, but we can't write it like that because that looks like we have 2 hydrogens. That's not the case. We have 2 hydroxides, so we write it like this. So this is copper 2 hydroxide. All right. Let's try a couple more examples. I'm going to write them out, and then you can pause it and give them a shot. Iron 3 oxide. Let's do calcium sulfide, and let's try sodium bromide. All right, pause it now, unpause it once you get them. Okay, so iron oxide, Fe and O. Crisscross the charges, 3 plus and 2 minus, Fe2O3. That's iron 3 oxide. So calcium sulfide, we have Ca and we have S. Write in our charges, crisscross those, and we get Ca2S2. However, this is not an acceptable answer. You always want to have the least common multiple with those subscripts. Reduce it to the simplest ratio that you can. So CaS2 is the same thing as CaS. Ca2S2 is the same thing as CaS. So there's your answer, CaS, calcium sulfide. And sodium bromide. There you go. Pretty simple. Okay, and there are plenty more examples on your test review, your study guide review sheet. So if you're still struggling, I would try those.